Now, today we will discuss on graph. So, suppose if we have a parallel plate capacitor, and in this parallel plate capacitor, if we insert a dielectric and a conducting slab having same thickness and now separated between the parallel plates by same separation, then what is the effect on electric potential and electric field according to graph? So you see that the graph between electric potential versus distance x and electric field versus distance x. If a parallel plate's capacitor is partially filled by a dielectric and a conducting slab of same thickness having dielectrics K and infinite. Why is K and infinite? Because a dielectric having dielectric constant K and a connecting slab, this slab having dielectric constant infinite. So now we just see there is a capacitor, there is a parallel plate capacitor is there. Its terminal is connected by potential positive and negative. Now here I want to put two slabs of same thickness. See, this one is dielectric, this one is dielectric, and this one is conducting slab. So the dielectric having dielectric constant K, whereas conducting slab having dielectric infinite. So its dielectric is infinite and this one having dielectric K. Now here we will talk its thickness. So each separation having same thickness. That means if you wanted to consider, let its thickness be x. So this one having x thickness, x thickness. In same manner, the thickness of this dielectric be also x, and this free space also having same thickness x. Now this conducting slab having dielectric constant infinite, having same thickness x, and the last free space having same thickness x. And then we have to plot two graphs. We have to plot. So here we are just going to be plot a graph between electric potential and x. We just put here x. One another graph in between electric field and x. This one is positive. So you just calibrate this separation x in 5 equal parts, because there is free space, that would be positive, and this one is negative, like that. So what happens? First of all, you think about this potential. So what happens about the potential between this gap x in this free space? So in free space, your potential, that will be kq by x. That means potential is how much? 1 by 4 pi epsilon naught, whatever the charge over there. So there is a charge plus sigma with the charge, surface charge density, minus sigma with the charge, surface charge density. So whatever the charge be there, suppose q be the charge, positive charge be there. So if you wanted to find the potential in between this free space, so that would be 1 by 4 pi epsilon naught q by x. So your potential is inversely proportional to x. Now you can see roughly that your potential is 1 by 4 pi epsilon naught q by x. So what's going to be there? That your potential is inversely proportional to x. So as well as you're going from left to right in this separation x, your potential will be decreasing according to this one. So you just take a graph here. Suppose here you are getting a maximum potential, that is E positive, and you just calculate a minimum potential, that is V negative. So your potential will be vary from positive terminal to negative terminal. It just between positive to negative. So you just make a graph like that, and you just calibrating 5 equal parts. So 1, 2, 3, 4 and 5. But right now you are going from left to right, from here to there, your potential will be decreasing, and that will be a rectangular graph. So just there is a decreasing order. Just like that. it is decreasing. But what happens when you wanted to find the potential in between the dielectric in its separation X? What happens there? That your potential that will be for this dielectric inside this dielectric, that your V is equal to 1 by 4 pi epsilon naught, and there is a K, and then Q by X. So separation is same, 1 by 4 pi epsilon naught is constant like that, but here there is a K. That means what happening here, that your V is varying inversely proportional to Kx. So your denominator is increasing. That means your numerator will be decreasing. Denominator increases, then your denominator increases, then your numerator will be decreases. But in decreases fast, not slow, it just decreases fastly. So there is a more curve like that. There is a more curve like that instead of this first one. Now again what happens when you are again enter from here to there, that means in this space. So there is a separation of X, same separation. So there is also a decrease in potential, electric potential by this way. So again you will get potential is in decrease mode, but there is a less incline. Inclination is like that, so like that, but decreasing in mode. Now, when you will enter in this conducting slab, what happening here, that dielectric constant is infinite. Okay, so there is an infinite dielectric, and you want to find potential. So in place of K, whenever you will put this K is equal to infinite, so something by infinite, that means there is potential will be 0. So there is a 0 potential for dielectric conducting slab. So V will be 0. So for 0 potential, you need to draw a parallel line to the x-axis. So there is a parallel line like that, a parallel line. Now here, again you are going to enter in this free space, saturation the same, and then again you have to see this condition that your potential is inversely proportional to A. So there is a rectangular graph, and there is a like that, and decreasing like first one. So this one, and this is called your V negative. So you just change this line from here to there like that. So this one is your graph like that. So V negative be there. And now I just want to plot in between electric field and separation. So separation be same, X. Same dielectric be there and conducting slab be there. But for this, but to plot this one, you must remember one thing, and you have to use the condition that how you can find this electric field. So the electric field, there is a relation for electric field that your E is equal to 1 by V by X. Use this relation. So accordingly, if you wanted to use this relation, so what happens? In case from here to there, how much is your electric field? Electric field is potential by separation. So your potential is for this free space 1 by 4 pi epsilon naught q by x, and there is 1x. So your electric field, that will be simply E is equal to 1 by 4 pi epsilon naught and then q by x square. So use this relation. So from here what you will get, that your field lines that vary inversely proportional to square of the separation like that there is a x from origin. Now there is a 2x from origin, again 3x from origin, and 4x from origin, and there is 5x from origin. But individually there is x, 2x minus x, there is again x, 3x minus 2x, again x, 4x minus 3x, again x, and then 5x minus 4x, again x. So in the same way, you have to take care also 5 separations. So just like 1, 2, 3, 4 and 5. There is 5 separations. So what happening from first separation x, your field lines be going by this one. So if you suppose the maximum field lines, this one is the maximum field lines, magnitude of maximum field lines. So for first separation x, that will be decreasing in order. So you will just take like that there is a decreasing in order. This one is the maximum value. Now when it enters from free space to this dielectric, so what happens here? There is 1 by 4 pi epsilon naught k times q by x square. That means E, that will be inversely proportional to 1 by k times x square. So 1 by x square, this one is also constant for this one. But there is one another thing, this dielectric constant, this one is a denominator. So your electric field, that E dash will be less than that of this E. So what happens here, that E dash is less than this E by a factor of k, So what happens here, one another electric field, that is E dash, and this one is by a factor of k. So here you will get, there is a field lines, one another field lines. Now whenever we will talk about again for this free space, so it will be just like this one. So for this space separation, your field has be again here. So this one is your electric field. Now whenever we will talk about this, so the you need to use this relation. In this relation you have to put in place of k dielectric constant infinite. So you will get there is 1 by infinite, that is 0. So 0 will be there. That means there is 0 electric field length. So you are seeing in this perpendicular line, here is a E max, there is a maximum electric field, and this one is 0, that is minimum. So your field lines will be here 0. Again you are going to enter you are going to enter in last section x, and again you are going to enter in free space, so you have to use this relation. So you will get again there is a maximum field lines, so your field lines will be there and there is a maximum field lines. So you can see how this is going to vary in this graph about your field lines in free space and dielectric, again in free space, in free space, in dielectric, again in free space, in conducting slab, and again in free space. See how this will be going to vary. So the maximum electric field line is passes through free space. There is a less free dielectric is passes through dielectric. Now again your free space, and in this conducting slab, because its dielectric constant is infinite, therefore there is a zero electric field is there. You see through this graph. Accordingly you see about its potential, that how this one is going to be vary. So use this graph in your concept, in your mind, for further solving in numericals. So just put there its separation x, there is 2x, again 3x, then 4x, and then 5x. But you must remember that the separation between the each calibration be x. Alright.